Welcome to Chemistry 101 online, the online presentation for the Unit 8 lab. So, as I said, this is the presentation for the Unit 8 lab. The Unit 8 lab actually is performing lab number 5 in your lab manual. However, I am going to provide a separate document, so you can pretty much ignore lab number 5. If you want to look at the instructions there, you're welcome to do that, but I'm going to basically present the ideas in this presentation and also in a separate document. So, what is this week's lab? What are we doing? We'll get to that soon enough. I want to give a little bit of background. And the background is related to the topic that we discussed last week. Last week, Unit 7 dealt with solutions, and this particular lab also deals with solutions. So the idea behind these labs is to have them present topics that are relevant either to the unit that you're doing this week or to a unit that you've done in the past, so that you're at least a little bit familiar with the concepts. But just to refresh everybody's memory, what's a solution? A solution is usually a liquid. Doesn't have to be, but for our purposes, we're pretty much always talking about liquids. It's usually a liquid that contains some dissolved materials, some materials dissolved in the liquid. The materials that are dissolved, and there can be more than one type of material, the materials that are dissolved in the liquid are called solutes, and the liquid that does the dissolving is called the solvent. And the entire mixture, the solvent and the solute together, make the solution. So this is stuff that we talked about in Unit 7. One of the other topics that we discussed in Unit 7 was solubility. If you remember, basically different liquids have limits as to how much of a particular solute they can dissolve. And the limit, the numerical limit of how much they can dissolve of a particular solute is called a solubility limit. So again, solubility limit is basically related to the fact that liquids have a limit as to how much of something they can dissolve. It turns out, and we mentioned this in Unit 7, you may or may not remember it, it turns out that the solubility limit of different materials is very often influenced significantly by temperature. And what I mean by that is that in general, if the temperature of a liquid is relatively warm, then that liquid usually is able to dissolve more of a particular material. And you say that it has the material has greater solubility in a warmer liquid. So you can imagine a warm Dunkin' Donuts coffee. It can dissolve a relatively large amount of sugar, because the solubility limit of this hot coffee can influence how much sugar the coffee can dissolve. And in general, if the liquid is relatively cold, then its solubility limit is reduced. It's usually able to dissolve less of a particular material. So if you have an iced coffee from Dunkin' Donuts, and let's assume that it's made of the same coffee, and you say you have the same amount of each type of coffee, the iced coffee is probably going to will only be able to dissolve significantly less sugar than the warmer coffee. And that is basically because the solubility limit of sugar in these liquids is influenced by the temperature. Warmer temperature, you can dissolve more. Colder temperature, you can dissolve less. So again, we will get to the whole point of the lab, but in a moment. But right now, I still want to mention a few things more about solubility. Another point about solubility is that if you have two different materials, so you can have material A and material B, that both dissolve in a single liquid, sometimes one of the materials can be very soluble, and soluble just means, very soluble means that it dissolves easily in some particular liquid, and maybe the other material is poorly soluble, and what that means is that it does not dissolve easily into that material. And this is true in a lot of cases. There are many different chemicals. You can imagine, you try to dissolve chemical A and chemical B in water. Maybe chemical A dissolves easily, and maybe chemical B doesn't dissolve quite as well. So what's the point of bringing this up? Well, it turns out that, and here's an example. Imagine that you have your Dunkin' Donuts coffee, and you have two different materials. You're trying to dissolve table salt, and you're trying to dissolve sugar simultaneously in this coffee. And it might be true that one of these materials is really soluble, is easily dissolved. Maybe it's the table salt over here, and maybe the other material, like the sugar over on the left, is not as soluble. It turns out that you can often use this behavior, the fact that some materials dissolve easily in a liquid and other materials don't dissolve easily in a material, to our advantage. Well, advantage for what? We'll get to that in a second. So I've spent the past couple of slides discussing solubility and different features of how materials can dissolve in liquids. Solubility is basically the main idea behind this particular lab. So what you're going to do, and again I'm going to tell you in more detail in a second, you're going to take advantage of the fact of solubility differences, the types of solubility differences that I was talking about on the previous slide. In other words, sometimes material A dissolves easily in a liquid and material B does not dissolve quite as easily in that particular liquid. What are you going to do specifically? What you're going to do is you're going to take 4 aspirin pills and you're going to obtain pure aspirin from these 4 aspirin pills. So you might ask yourself, and this is a perfectly reasonable question to ask, it's not already pure? Isn't this pill just 100% aspirin? And the same thing for this pill over here? No, it's not. There are many other ingredients that are embedded in this pill in addition to aspirin. There are fillers, there are materials that prevent your stomach from becoming irritated by the aspirin. There are ingredients embedded in this pill that help to keep the aspirin stable for long periods of time, just in case it sits on a shelf for a year or so. So in addition to aspirin in this pill, there are other materials that are mixed into the pill for other reasons other than curing your headache or relieving a little bit of pain. So what you are going to do is you're going to take these pills and you're going to actually extract relatively pure aspirin from them by taking advantage of the fact that aspirin dissolves to a certain degree in water and the other fillers dissolve to different degrees in water. The aspirin has a different solubility than the other materials embedded in this pill. And so that's why we're talking about solubility. Now what you're going to do in more detail, I'm going to show you on the next series of slides. So how are we actually going to obtain purified aspirin from aspirin pills? Well, the background information that you need to know is that aspirin dissolves well in water. It will dissolve in water pretty much completely, this 4 pills of aspirin, at very high temperatures. Because, as we mentioned earlier, the solubility of many things increases as the temperature increases. So if we have very hot water, the aspirin will probably dissolve in it. In contrast, aspirin dissolves very poorly in water at lower temperatures. So if you have cold water, or even room temperature water, aspirin doesn't dissolve very well in it. And we're going to take advantage of this fact. There's a difference between the solubility of aspirin and the solubility of many of the other fillers in the aspirin pill. Most of the other fillers in the aspirin pill, most of the things that are not actually aspirin that are mixed into this pill, actually dissolve very well in water at high and low temperatures. And we're going to take advantage of the fact that water only dissolves well at high temperatures, and the fillers dissolve well pretty much in water at all temperatures. At this point, I'm going to take you through many of the different steps of the lab, trying to explain what's going on along the way. So at one of the beginning steps of the lab, basically what you're going to do is you're going to take 4 pills of aspirin. They're shown here number 1, 2, 3, and 4. They are 81 milligram pills of aspirin, and you're going to grind them up in this little dish and using this little device here. And the 2 of them together are called a mortar and pestle. And to be honest with you, I can never remember which one is the mortar and which one is the pestle. You can probably look it up and figure it out, but I'm too lazy to do it. So you're certainly not required to know which one is which. However, you should know that pharmacists and other people very often use mortar and pestle to grind up materials. And what you're going to do is you're going to grind up the aspirin. And once you're done grinding, the aspirin is basically going to look like this powder over here. So you've basically smushed up all of the pills and broken them into tiny pieces. Then you are going to take the powdered crushed pills and put them in a test tube. And they're going to sit at the bottom of the test tube like that, more or less. And then what you're going to do is you're going to add about 10 milliliters of water to your test tube. That contains the crushed aspirin pills. And if you look, if you sort of shake up the water and the crushed aspirin, you will see that the liquid is very cloudy. What this basically means that the cloudiness comes from the fact that a lot of the material in that crushed pill does not dissolve in the water at room temperature. So a lot of this cloudiness is actually due to the aspirin. Some of it is due to other materials that are part of the pill that also don't dissolve so well in water. It's also true that some of the other fillers in the aspirin pill have already dissolved in the water. It's just that it's hard to see because the water is cloudy, and when something dissolves in water, you're just not going to see it. So you can't really see the stuff that's dissolved, but you should realize that this cloudiness is due to the fact that there are many ingredients in that pill, including the aspirin, that do not dissolve so well in water at cold temperature. So now we have this mixture. There's aspirin sort of floating around, making this liquid cloudy, so it's not well dissolved. There are other ingredients that are well dissolved in the liquid. You can't see them. And furthermore, there are even other ingredients that were part of the pill that, just like aspirin, do not dissolve well in water at room temperature. You're going to take this test tube and you're going to heat it up. And in this case, in this particular lab, since this is an online lab, you're going to heat it up in a pan, probably on your stovetop. So here's the test tube that had the crushed pills and the water. You're heating it up. Notice that I am holding the test tube with a test tube holder, and I am using a pot holder so that I don't burn myself, because this piece of metal is going to be extremely hot and you should not touch it with your bare hands. So basically you're boiling water, you're heating up the liquid in the test tube, and what that means is if you look carefully at that very hot water, so now this is a picture of the test tube after the water has been heated significantly. What you can see is the liquid in here, it's still cloudy, but it's much less cloudy. The reason it's much less cloudy is that a lot of the aspirin is now dissolved in the liquid and you can't see it, and the reason it's dissolved is because aspirin is much more easily dissolved in very warm water than it is in room temperature water. So now you can imagine, I want you to think of this liquid as this liquid has dissolved some of the fillers in the aspirin pill. It has dissolved the aspirin as well because it's very hot water. But it's still a little bit cloudy because there are other materials that were also embedded in the pill that don't dissolve in water even when it's very hot. And you can see some of this material is just accumulating at the top of the liquid here. So it's just some junk that was part of the pill that does not even dissolve in water, even when water is extremely hot, when it's near 100 degrees Celsius. And there's also some cloudiness due to some of the materials that don't dissolve so well in water either. So now you've got aspirin dissolved in your water, you have some other fillers dissolved in the water, and a lot of stuff that doesn't dissolve. The first thing that we're going to do is get rid of this stuff that does not dissolve in water even at high temperature. The way that you're going to do that is you're going to pour your very hot water into a funnel that contains a piece of filter paper. So this white stuff is filter paper, and this white stuff is basically going to let the water pass through down into this test tube, and it's going to capture all of the cloudy stuff. It's going to capture this junk up here, and it's going to capture the cloudy material that is making this liquid cloudy because this material is not actually dissolved in the water. And what's going to happen is the water and whatever is dissolved in it is going to pass through this filter. It's going to fall down the funnel and into this new test tube. Then what you're going to do, so inside of this new test tube, and here's showing the liquid at the bottom of the tube. The liquid in the bottom of this tube now does not have this junky material here. What it basically has is relatively warm water that has aspirin dissolved in it, as well as some other fillers that also easily dissolve in water. And what you're going to do is you're going to take this test tube now that has the aspirin dissolved in very hot water, and you're going to put it on ice. You're going to put it, this is called an ice bath. Basically, I just took a pot of water and threw a whole bunch of ice in there, and now the test tube is sitting at very cold temperature. And if you remember what I said earlier, aspirin dissolves well in very hot water, and it dissolves poorly in very cold water. The other fillers dissolve well in water at both hot and cold temperatures. So when you chill this test tube, what is going to happen is the aspirin will basically undissolve, if you want to think about it that way. That's a very informal term. What chemists usually say is the aspirin is going to precipitate out of the solution, which means just fall out of the solution. Sometimes chemists say that the material is going to crystallize. In other words, it's going to form little crystals and basically become solid. And when you take this test tube out, you'll leave it in the ice for about 5 minutes. What you're going to see is these little flakes, these little crystals, and those are crystals of relatively pure aspirin. So you will have ground up your aspirin. You will have removed many of the fillers just because they don't dissolve in water at all, whether the temperature is hot or cold. And then you're going to chill your water that contains aspirin in it, and the aspirin will actually undissolve or crystallize or precipitate out of the solution, and then you're going to collect this crystallized aspirin, and I will explain how to do that in the document that I send to you. So that is the end of this video introduction to the lab. Hopefully it made sense. If it doesn't, you can certainly email me or contact me in other ways.